Okay, this is lesson 4.1. In this chapter, or the first part of the chapter, I guess you would say, is over radicals, which we have done before, but we've only done the square root. So the radical, that's just the symbol itself. The root index is the number in the left corner. And the radicand is the stuff underneath. Okay, so for example, if I have something like the cube root of 5x, 3 would be the root index, and the 5x would be the radicand. Okay, if a radical does not have a root index, the root index is 2. So this is the same thing as this. Those mean the same thing. Okay, so 3 and 5, I'm skipping these because we have enough examples right there. So I want to change these from exponential form to radical form. So I'm going to go ahead and put a radical. The exponent becomes the root index. The number that's by itself becomes the radicand, and that's equal to the base. Okay, this one, I've got the radical. Since the exponent is 2, I don't really have to put a 2 there. The number by itself now goes underneath, and then the base is about 6.99. Now we're going to do the opposite. So on 7 and 8, I am giving you a radical, and you're going to give me the exponential form. So 7 now becomes 1.912 becomes the base. 3 becomes the exponent, and that is about 7. So the number underneath becomes the number by itself. And these two sections are just opposite. All right, so number 8, the number by itself becomes the base. The 6 is now the exponent, and the number under the radical is 729. So these two numbers pretty much just switch spots. If this has the root index with it, this number is going to have the exponent with it. Okay, moving on. The root index.
At this time, we need the following students with the last names of H through L. Again, that's students with the last name of H through L. Please report to the Media Center to get your pictures taken. Thank you.
All right, there's going to be a lot of interruptions, I think, during these notes, but that's fine. Anyway, the root index tells how many roots each radical has. So when evaluating or simplifying an expression, we only give the principal root, and I'm going to tell you what that is in a second. When solving equations, we list all the roots. Okay, so if I have an odd root index with a negative number underneath, you're going to get a negative answer. Because this number, if I multiply this number times itself 3 times, I in fact get negative 8. So now, if I have a negative number underneath, I can only do the problem if my root index is odd. This one, for example, let's say I have the square root of negative 9. Well, that's going to give me 3i. So this is going to give me an imaginary solution. I should have said this is more of a negative answer. Yes, my answer is negative 2, but a problem like this will be a negative. All right, let's see, I have the cube root of positive 8. That's going to be 2, so I'm always going to get a positive answer. And if I have the square root of 9, I'm going to get 3, which is also a positive answer. So in summary, if I have a positive number underneath my radical, no matter what your root index is, you're going to get a positive answer. Now, it does depend if you have a negative number underneath. If you have a negative number underneath, it might be negative, it might be imaginary. It's imaginary if your root index is even. It's negative if your root index is odd. All right, 12 and 13. Let's cross these two off. So determine the number of roots. Well, there's going to be 3 because that's the root index. Now I got to find the principal root. That just means what is the cube root of 125? That is 5. And C, you just want to tell me why it's 5? Well, that's because 5 to the third power is 125. I'm kind of putting these two things together. Okay, 13. First of all, I have to decide if I'm actually going to get an answer. Well, since I have a negative underneath, and this is odd, I am going to get an answer. It's going to be negative, though. There are 5 roots. The 5th root of negative 32, that's negative 2. Because if I take negative 2 to the 5th power, I in fact get negative 32. All right, 14 and 15 we are skipping. Let's go on to the next page. Okay, so I'm crossing off 16 and 17. I'm crossing off 21 when I get there. Okay, so if the root index is odd and I have a negative number underneath, my answer is going to be negative. If I have the square root of x times the square root of x, I just get x. If I have 3 cube roots, my answer is just x. If I have the 4th root and I want to just get x, I need 4 of total of these. So I need 3 more of these to just get x. And this is going to come when I do division, which isn't until I do 4-2 actually. But anyway, that's a good thing to know. All right, we're going to simplify. So what I need to do first of all on 18 is to figure out if I'm going to have a negative, if I want to bring out a negative, or if I want to bring out an I. Well, since that's negative and that's odd, I'm going to bring out a negative. And now I'm just going to break this down. Now this time I don't need to find a perfect square because the root index is not a 2. We've only done square roots before. So we need to figure out 2 numbers that multiply to get 250. They can be any 2 numbers. Let's do 25 and 10. 25 is 5 and 5. And 10 is 5 and 2. Okay, this time I need 3 of the same number because that is what my root index is. So I've got 3 5s. So I'm going to bring out one group of 5s. I also have a negative out there, so I'm going to bring the 5 out with the negative. This 2 is left by itself, so I'm going to leave the 2 under the radical. So this is my answer to number 18. Number 19. Let's see, 2 numbers that multiply to get 400. I will do 40 and 10. 40, I'll do 5 and 8. I'm done with 5. 8 is 2 and 4, done with 2. And 4 is 2 and 2. Now I got to do 10. 10 is 5 and 2. Okay, this time I need 4 of the same number. Let me clean this up a little bit. So I'm going to rewrite this. So 400 breaks down to 1, 2, 3, 4 2s and 2 5s. Let's see. All right, that should be good. Let me double check real quick. And here's how I'm checking it. I'm just doing 2 times 2 times 2 times 2 times 5 times 5. I'm making sure that's 400. Okay, I'm good. Okay, so again, I need 4 of the same number. I got 4 2s. So this group comes out. I am left with 2 5s underneath, so I'm going to multiply those together and get 25. So that is my answer to 19. Okay, let's add some variables in the mix now. So we have never done this before, actually in any class. So what I want to do first is I want to make sure the variables underneath have exponents. Well, this y does not, so I'm going to put a 1 there. And then if you notice, it says to divide. So I'm going to divide the exponents. But first of all, I'm going to bring down the 5th root. Okay, 5 goes into 10 exactly 2 times. So all of the x's come out, and I'll put a 2 as an exponent. 5 does not go into 1, so the y stays underneath. 5 goes into 27 5 times, so I'm going to bring out a z to the 5th. 5 times 5 is 25 though. I have 27. So the extra 2 are going to go underneath. So this would be my answer to number 20. Okay, let's move on to the next page. I'm skipping 21. On the last page, I'm going to skip 23, 24, and 27. On 22, I have numbers as bases, but I also have exponents. So whenever you have exponents, your bases stay the same. So I'm going to go ahead and bring down the 5th root, and I'm going to go ahead and divide the exponents. 5 goes into 8 1 time, so I'm bringing out 1, 2. Well, there's really a 1 there. 1 times 5 is 5. I have 8, so the other 3 2s are going to be underneath. 5 goes into 11 2 times. Well, 2 times 5 is 10. There's 11, so there's 1 more underneath. Now I need to clean this up a little bit. So I'm going to take 2 to the first, which is 2, times 3 squared, which is 9, which is 18. And then this is going to be 8 times 3, which is 24. So this is my final answer. Now we're going to put all this together, because if you notice on 40, it doesn't have an exponent. So if you have a number with not an exponent, or without an exponent, you're going to break that down. So I'm going to do, let's see, 2 and 20 will work. I'm done with the 2. 20, I'll do 2 and 10. And then 10, I'll do 2 and 5. So I need 3 of the same number. Looks like I got 3 2s. But I'm going to bring out 1 group of 2s. And then the 5 stays underneath. Okay, now I've got my variables to look at, which have exponents. I'm going to divide. So 3 goes into 6 exactly 2 times, so I'm going to bring out an x squared. 3 goes into 5 only 1 time. Well, 3 times 1 is 3. I need 5 total, so I have 2 more y's underneath. Now I'm going to clean this up a little bit. So this is going to be 2x squared y. And then underneath I've got 5y squared. So that is my answer to 25. And then 26 is just like 25.
At this time, we need the students with the last names of M through R. Again, that's students with the last names of M through R. Please report to the media center and the doors across from the main office. Thank you.
Okay, so last one on lesson 4.1. So I'm going to break down the 162. Let's do 2 and 81. And then 81 will be 9 and 9. And the 9s break down to 3s. Okay, so this time I need 4 of the same number. Looks like I got 4 3s. I'm going to bring out one group of 3s. And then the 2 stays underneath. Make sure you, whatever your root index is, you bring it down in your answer. Okay, now we're going to look at the variables. I'm going to divide. So 4 goes into 10 2 times, but 2 times 4 is 8. I need 10, so there's 2 more left underneath. 4 goes into 12 exactly 3 times, so all the y's come out in front. And therefore, there is my answer. So that is lesson 4.1.